maximum, minimum or points of inflection. These are commonly referred to as stationary points on curves. Now, when we have a curve and we have these points where the gradient switches from an increasing to a decreasing function, or a decreasing to an increasing, or an increasing to a decreasing function, these points here are referred to as stationary points. And you can be asked in the exam to find the coordinates of the stationary points to a curve, or to discover whether a stationary point is a maximum or a minimum point. So a maximum point is where the gradient is increasing and it decreasing, and a minimum is where it is decreasing and then it begins to increase after the stationary point. So that is a maximum, this is a minimum, and that is a maximum. So there's 3 stationary points on this curve, of which 2 are maximums and 1 is a minimum. And our points of inflection is as shown here, where you've got an increase in gradients until this point, and then you've got increasing gradients again afterwards. So that is a point of inflection where it stays the same kind of function, whether it's an increasing or a decreasing function both before and after the point, the stationary point. Find the coordinates of a turning point on the curve with equation y equals x to the power 4 minus 32, establishing whether it is a maximum or a minimum point or a point of inflection by considering the points either side of the turning points. So we're asked to firstly find the coordinates of the stationary point, and then to use that to discover whether it's a maximum or minimum or a point of inflection. So remember, to discover where the points are for the stationary points at coordinates, we need to first differentiate and set the differentiation, the dy by dx, equal to 0, because the gradient at a stationary point is always going to be equal to 0. So first thing, we've got our equation y equals x to the power 4 minus 32x. If we differentiate this with respect to x, we get 4x cubed minus 32. Now remember, we're going to set dy by x equal to 0 as the gradient at a stationary point is equal to 0. So now we've done this, we can now find out what the value for x is where we have our stationary point. So 0 is equal to 4x cubed minus 32. Obviously add 32 to both sides and we end up with 4x cubed is equal to 32, which now 32 divided by 4 is x cubed equals 8, so x is equal to 2. So to find the coordinate of this stationary point, we need to take our value for x of 2 and substitute it into our original y equation. So our original y equation is x to the power 4 minus 32 x. So y equals 2 to the power 4 minus 32 times 2. So the y is equal to minus 48. So our coordinate for our stationary point is 2 minus 48. Now it asks us in the question to find out whether this is a maximum, minimum or point of inflection by considering the points either side of a turning point. What this means is we want to look at the gradients on either side of the turning point. So now we know that the turning point is at x equals 2. We want to find out what the gradient is at x equals 1 and when x is equal to 3. And then we can discover whether this is a line, a maximum, minimum or point of inflection. So the best way to do it is to quickly set yourself up a little table with our x value and our dy by dx. values. So we're going to substitute in 1, 2 and 3. Well, we know if we substitute 2 into our dy by dx, which is 4x cubed minus 32, we know we get the answer 0. If we substitute 1 in, we're going to have 4 times 1 cubed minus 32, which is equal to minus 28. And if we put in 3, we get 4 times 3 cubed minus 32, which is equal to 76. So our gradient here is a minus and here is a positive, so that means we're going to have a curve like that, which means we've got a minimum. This point represents a minimum. Now, that method is a fairly long-winded method for finding out whether a point represents a maximum or a minimum or point of inflection, but you could be asked to do that in an exam. The quicker way of finding out whether a point is a maximum, minimum or point of inflection is to consider the second derivative of a curve. Now, we did look at the second derivative at the very end of core 1. So, to do this, to look at the stationary points, we have to differentiate firstly once, so, and then we need to set it equal to 0, and then we need to differentiate again and sub in our values for x. So that's what we're going to do. We're firstly going to differentiate with just the once, and then we're going to find out where the x coordinates will be for the stationary point, and then differentiate it again to find out whether the stationary point represents a maximum, minimum or point of inflection. So it says find the stationary points on the curve with the equation y equals 2x cubed minus 15x squared plus 24x plus 6, and determine by finding the second derivative whether the stationary points are maximum, minimums or points of inflection. So first thing we're going to do is we need to find out where our stationary points are. So we need to differentiate our original curve. So that's going to be 6x squared minus 30x plus 24. And remember, to find out where the stationary points are, we need to set dy by dx equal to 0. So 6x squared minus 30x plus 24 is equal to 0. Now, the easiest thing we do at this stage is divide through by 6, so that will be easier, one would hope, to factorise, which it is. You factorise quite nicely to minus 1 and minus 4. So our two values for x are 1 and 4. Now if it asks us to find the coordinates, we just need to substitute our 1 and our 4 into our original curve to find out what our y component would be. And if you do that, you end up with the coordinates 1, 17 and 4 minus 10. Now we know that our 2 points where we have our stationary points are at x equals 1 and x equals 4. We can now find the second derivative of our original dy by dx. So our second derivative, which we first covered in core 1, which is basically differentiating our dy by dx, we end up with 12x minus 30. And what we're going to do is we're going to substitute in our two solutions for x, our 1 and our 4. So if we just split our page up into 2, we're going to have x equals 1 on this side and x equals 4 on this side. So it's going to be 12 times 1 minus 30, which is equal to minus 18. And if we put 4 in, we've got 12 times 4 minus 30, which is equal to 18. Now what do these two values mean? Well, when you end up with a negative value for dx squared y over dx squared, it means that you're representing a maximum point. So if dx squared y divided, sorry, d squared y divided by dx squared is less than 0, you have a maximum point, and if d squared y divided by dx squared is greater than 0, you have a minimum. Now, the only time you need to worry is if you have it equal to 0, it may mean it's a point of inflection, it may mean it's a maximum, it may even mean it's a minimum, and the only way to decide which one it is to try the method we've just done on the previous example, to consider the points on either side of the stationary point and look at the gradients. So what we've just found here is that when x is equal to 1, we've got minus 18, which means that this is a maximum on this side, and when x was equal to 4, we've got 18, which means that that one represents a minimum. So our two solutions at x equals 1, when we substitute it into the second derivative, we get a maximum, and when we substitute x equals 4 into our second derivative, it gives us a stationary point that represents a minimum.